Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is the KO Moto Rush controller. I couldn't help myself. I had to take it apart, and so I did. I was pretty darn sure of what I would find, and so pretty on the outside, ugly on the inside is the name of the game. And I would have to say that's true for the F-Spec and the Pro controller as well. Looks great on the outside, inside is dismally shoddy, bad design work and construction. And this is no different. So that's quite attractive. I can't deny it. That would be something that I would want on an EV of mine. This is a nice hunk of aluminum. Lots of CNC time was spent in making that part. So yeah, it looks really nice. Costs a lot of money to make that part. It did. These spots in here, I thought that those might possibly hold down like the metal core printed circuit board. They do not. Those actually have these in them. Yeah, so it's an M5 screw with a couple of aluminum hickey-doos on there. So they're purely cosmetic. They do absolutely nothing. They simply add cost to the controller. And that's all they do. So if you are looking at those things and thinking, oh wow, that's really cool. Like one of my theories was about them when I first saw the controller was possibly they hold down this heatsink portion to like the rest of it. So like the eBMX X9000 controller, you have screws that hold down the front plate, and you can take that all off so that you can put a different heatsink on it or plant it onto some big hunk of metal like a bigger heatsink or a water block or whatever. All those things crossed my mind that maybe those did that, but no, they are purely cosmetic and they do nothing but add cost to the controller and no performance or other functionality in any way. They are just pretty and that's it. So, yep, I would call that highly disappointing. I was really hoping that KO Moto would copy eBMX in that regard and make the heatsink removable, and they didn't even bother to do that. Alright, so let's look at the inside of this thing. So this is a hefty piece of aluminum, no doubts about that. That's probably going to make for a pretty good heatsink. But you know, you still have all the same thermal problems that you ever did with KO controllers, and this one is not going to be different. This piece of plastic right here, as you can see, there are no molding marks in here, so you have no idea what it is. But that's pretty typical for Chinese products, that they don't put any molding marks because it's ABS. In fact, this is the same flexible stuff that's on my Pro controller. It looks exactly like it as well. So I'm going to say that that is a Pro back cover. Literally no changes whatsoever. The only real change here is they made this deeper and had to add a shoulder back here so that the center power stage has got something to rest on. Otherwise, this is a KO Pro shell in every way. All right, let's move on here. I guess I should talk about that first. You can see that there was caulk around here, silicone caulk. I peeled all that away to kind of clean that up, but that was sealed up against the board. At least this time, these rubber or silicone grommets are sealed properly to the ABS plastic. On my Pro controller right here, it was not, so I added some more silicone right there. So this is better done than that one. That might have just been, you know, typical quality control that KO Moto lacks completely. Issue why mine wasn't done better, but this one, you know, those rubber or silicone grommets were done better. So we set this on the floor, and let's look at the logic board, because it is a little bit different than like the Pro or the F-Spec logic board, but not dramatically so. So here is that. So first of all, this has to drive 48 MOSFETs, and as a result, you have an extra MOSFET driver or gate driver, so you've got 2 of them for one phase, 2 more for another phase, and 2 more for the third phase. Anyway, you know, because this is a 48 MOSFET controller, which is stupid, is completely not needed in any way, shape, or form. The particular MOSFETs that KO Moto uses, if you have 8 of those in parallel, like you do here with 48 of them, your magical upper limit, because this is the limit for the MOSFETs, is 3,800 amps for 8 of those in parallel. And if you were actually needing 3,800 amps, well, all I can say is you must be driving a dragster. Certainly not a Surron, so you will never need that much amperage anyway. And if the whole thing was designed properly, 4 MOSFETs in parallel is actually quite plenty. You still have a maximum of 1900 amps with 4 of those same MOSFETs in parallel. So 48 MOSFETs is such massive overkill, it's not even funny. And you can't use them because of the design flaws of the power stage that make it impossible to use them even close to their upper limits. So anyway, that will come when I talk about these, which is in a second video. All right, so as is typical for FAR driver development, you have 2 current loops, and that's what this is. You have the exact same CPU. You know, a lot of these components are very similar. Same gate drivers, same op-amp package, so on and so forth. When I do a macro video on this controller, I will be looking up these part numbers so we can look at them more specifically. So we'll know like what the current limits are of these gate drivers. We'll look up this op-amp and whatever these 2 parts are, which I didn't do on my Pro controller macro video. So all that stuff is coming. You know, we'll look at everything here up nice and close so you can see all that detail for whatever it is. So here's your CPU, here's your 3.3 volt linear regulator. Over here is a 5 volt linear regulator, 7805, and then your main DC to DC converter that is taking battery voltage and dropping it down to 12 volts. So you know, a linear regulator rather than a switcher, which is cheaper. So that's a change from the previous controllers. But then again, that's pretty typical. You know, again, cheapest possible current sensors you can use for this kind of a design. Yeah, there's much better ways of doing it that cost more money, and of course, that's never going to happen because that's not the KO Moto way. You'll notice this yellowish stuff that's underneath all of the capacitors. So that's a single piece of Kapton tape. You can see that it's torn off here. The corners are peeled up. Basically what they did is thin film caps commonly, and I've taken one apart and shown you one that came out of the back 8000 controller. Took one apart and unpeeled it so you can see the insides of it. These are the exact same kinds of capacitors, just that these are Chinese ones rather than like Nichicons or US Chemicons, which are really good brands. Anyway, yeah, thin film electrolytic capacitors. So the shells on them are coated in a thin plastic layer. It can short out or not be a insulator like it should be. Most electrolytic capacitors, they do have a heat shrink coating around the aluminum can underneath them. And so to get around this little problem, they slap down a piece of Kapton tape because underneath each one of those capacitors is battery plus and battery minus. And it is possible that the cans of these capacitors could short across battery plus and battery minus. So they, you know, as you can see, it's pretty awful. That corner's all peeled up, it's all crinkled, it's obviously torn, not cut, nice and neat. Same thing here, it's pretty well shredded. They hacked it out of this hole, this isn't even stuck down. And as you can see, it's hanging over that hole. Same thing here, it's just kind of hacked out of there. Hack, 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 hack. Another little section stuck underneath there, random little pieces of Kapton tape. To insulate these capacitors from battery plus and battery minus. If you care about what you do, first of all, you at least lay your Kapton tape down rather than leave wrinkles in it like they did here. And you lay down multiple layers of it. But if you really care, then you make a purpose-built part, a sheet, and it could be fiberglass, it could be a thicker piece of Kapton, it could be made out of a dozen different materials, could be made out of polyester. The possibilities are truly endless. And then you make a purpose-built insulator sheet that covers that area, in which case it looks gorgeous, it looks professional, it looks like it was done by somebody who cares. And, well, KO Moto doesn't. This is your typical KO Moto style of things. Do it the poorest way possible. And, well, here is their ever so expensive Rush controller, still shoddily done, still sloppy as ever, still just as yuck as ever. At least this one doesn't see any evidence of repair done here. I haven't looked super close, but I haven't found like little blobs of solder on it, which I found 2 of those on my Pro controller. You know, like this chip was replaced on my Pro controller. You know, there were several places that were clearly resoldered, and I haven't really noticed any of that here. Like on my Pro controller, there was some components right over here by the CPU that had clearly been replaced after the fact, and I don't see evidence of any of that stuff right now. Perhaps that will show up when I do the macro video, which will come. All right, bottom side of this board. Okay, so let me flip it over so we get battery plus on top. So here is your Bluetooth module. Why they stuck it on the bottom, I'm scratching my head on that one. This piece of copper right here, this is an RF shield. This is to keep the noisy power stages from cluttering up and making noise for the small electronics. And here they put the Bluetooth module underneath that RF shield. So if you know anything about Bluetooth, that's basically 2.4 gigahertz. That's a microwave signal. It doesn't pass through copper very well. It doesn't pass through aluminum very well. This is a wrong place to put this. They should have left it here on top like it was on the Pro and the F-Spec, and they stuck it on the bottom. The pins stick up. How hard would it have been to solder it onto there? And they didn't. They put it on the bottom where RF signal penetration is going to be worse. No idea why they did that. The board flex is a lot less. Oh, so good job there. But you could have done that on the other side, KO Moto, and gotten a lot better signal penetration. Because on the other side of the board, all the signal's got to do is pass through plastic. So that works pretty good. All right, so as you can see, all that brown grunge on there, this is flux. This is exactly the same thing that was in my KO Pro controller. You know, no attention to cleaning up after the fact. After all those capacitors were hand soldered, and in fact these connectors, the Bluetooth module and this connector over here, are also hand soldered, along with those two hulls. After that was all done, they said, it's good to go, ship it. Don't bother cleaning anything up. This is something where you take pride in your work. I have been soldering for about 30 years. That's more than many of you have been alive. And I wash my boards after I am done soldering. If I were to show you something that I soldered, which I actually could if I hadn't actually screwed it down, because right back here is the Tronic 750 board, which I've replaced all the MOSFETs in it. And if I showed you that board, you would not see flux anywhere. It is clean, clean, clean. Because that's attention to details, that's caring about what you do, and KO Moto does not care. They never have cared. They will cheap out anything every way they can. And that's just how they do business. You can see all this bloppy solder on here. I believe what they were trying to do was add solder to that big path right there that goes to that circuit trace that's right there that screws down to a stud. And so somebody just kind of slapped some solder on it and did a really poor job of it. Same thing here and same thing there. So pretty crappy solder work all the way around on here and no cleanup whatsoever. Here is your battery plus bus across here. And I'm going to call that what it is, even worse than it is on the Pro and F-Spec, because it's now thinner. It is across the top of the board too, but it has got even less area on here than it does on those. So just like the S-Spec and Pro controllers, when they burn out, this goes too, and it's going to do the same thing here, because once again, this is part of your battery plus bus, and it shouldn't be. This should be about ripple filtering only, and both power stages are dependent on this for current. And that has not changed ever. So yeah, that's still going to burn, and you've got a thin spot here just like you did before. There's a thin spot there. Any one of those might burn. It's kind of hard to say which ones are going to go, but those are the likely places. Back over here you have the third phase, which is not reinforced at all, and there used to be a stud right here, so now there's not. Anyway, that part right there is probably not going to burn anymore just because it doesn't do much. But yeah, that was potentially going to be a burn spot on like the Pro or F-Spec, and well, that part's fixed just because it's just not being used as a current path anymore, which is good. That's how it should be. But yeah, all of this is still just the same awfulness. Here's battery plus right here. And yeah. This is where battery plus comes in the board. It's not like in the middle or anything. Yeah, everything about this is still just like, yuck. Terrible, awful, yucko. Yeah. KO Moto could have done such a better job. And they didn't. Anyway, when they tell you that top to bottom, took it back to school, yeah, they literally did almost nothing. This is a Pro/F-spec logic board in almost every way. Same shoddy design, same crappy placement of parts, same cheaping things out. Yeah, it's the same, and it's still based on far driver development. Anyway, I believe that's everything I want to talk about in this video. So, yeah, that's the KO Moto Rush logic board and the shell.